Hello everyone, this is our lecture number 3rd in which we start our second unit according to RTU syllabus. In this unit, we covered fundamentals of reinforced concrete, characteristic strength, characteristics, loads, types of reinforcement, working stress method, and analysis and design of singly reinforced beam by working stress method. This lecture is contained fundamentals, concept of RCC, characteristic strength, characteristics, loads, and types of reinforcement. So now we start this topic. First, you have to know the reinforced concrete construction phase. First, we have planning phase. After that, we have to structural analysis and design. Means if you want to construct a building, first you have to plan. After that, you have to analysis and design the elements, because our building is made up of some elements. Such elements are beam, slab, and column, and foundations. So in this subject we study about the analysis and design of these elements. So after planning phase we have to find or design the structural elements. If these are safe and serviceability requirement is satisfied, then construction phase is start. If design and analysis is not up to the mark, then we have to design that part again and repeat the same process. So here we discuss some points for structural analysis and design. Selection of most appropriate structural system to bring the architect concept into being. Means architect is prepare a map of construction building, and the structure engineer is make a loading part. Means structure engineer is develop all the loads part and elements part. So after that we have estimate of loads on structures, structural analysis for estimation of stresses, and structural design of actual proportions. Means how much material you require, like concrete, reinforcement, size of column, size of beam, etc. These all part is done by the structural engineer, and this part is done with safety and serviceability, because these two requirements is necessity in our buildings constructions. After that, submissions of drawing. After that, structure engineering submitting the drawing to the site engineer, and site engineer is prepare or make a construction with the help of this drawing. Now there is some difference between plain concrete and reinforced concrete. Here we describe that plain concrete is made by cement, aggregate, water, and admixture. Concrete is generally prepared at the site itself, although ready mixed concrete and precast concrete are also used. Concrete is compressive strength is very high, and concrete tensile strength is very low. So these two images shows concrete is strong in compression but weak in tension. A man is standing on a beam, so it is comfortable for them. But if two men is stretching this beam, then this beam is collapsed. That show that this part is weak in tension. So when we applied a load in a beam, here you see a cracks is occurring. If we increase the load here, then this cracks is widened, and after some time this beam is collapsed. But what happened if we provide a reinforcement here? Means steel embedded in concrete called reinforced steel. So here if we provide steel or reinforcement, that makes the sound RCC, reinforced steel concrete. So now if we applied a load here, so tension part is taken by this reinforcement and compression part is taken by the concrete. So if you see here, only hairline cracks is appear and this is not much perceptible. Okay, so steel embedded concrete called reinforced steel, and this steel is usually manufactured in factories under control conditions. It can effectively take up the tension that induced due to flexural tension, direct tension, diagonal tension, and environmental effect. Steel also impart ductility to the materials. Means if here we provide reinforcement and here we applied loading, this beam is deflected up to the mark. So steel is also provide the ductility to the material. Now in this subject, this type you see again and again in every questions. So this is the mix design. Here M is refer for mix and 20 is for characteristic compressive strength. Means we want to cast a cube of M25. M25 means you have to cast M25 cube. So 25 is for characteristic compressive strength, means your cube strength is 25 or more, not less than 25. So here we use for that M20. Now reinforced steel, here grade of steel is called yield strength of steel. It is specified yield strength may be treated as characteristic strength and its symbolic representation is Fy. Here M20, this is represented by FCK. Here 20 is represented by FCK and here steel strength is represented by Fy. There are number of types of steel. First one is the mild steel, which is less commonly used because of their low strength, medium tensile strength, cold twisted bar, that is high yield strength deformed bars, which is comes in 415 and 500. Fe is the iron, so it is come in 415 and 500. It is the characteristic strength of the steel. And TMT bars, thermomechanically treated bars. In these bars, inner core is soft and ductile and outer shell is very high tensile strength. Means this bar is totally protected from fire resistance and this bar is anti-corrosion. But this is the graph between stress and strain for a different steels. And modulus of elasticity you already know, 2 into 10 raised to the power 5 megapascal. Now characteristic strength and characteristic load. So characteristic strength for a concrete is compressive strength of concrete cube specimen of 150 mm dimension. Means it is defined as the strength of material below which not more than 5% results are expected to fall. Means during compression test in a cube laboratory, not more than 5 in 100 test results fall below the characteristics volume. Means this cube is designed for an M20. Now you cast 100 cubes of M20 and take in lab and compressive testing is done. So what you see, mostly result is come 20 or more than 20. Only 5% results is below the 20. Here we take 25. Here we cast M25 and we take several results. You see here only one result is below the 25 and other results are more than 25. Okay, so here we cast M25 and we know that FCK is equal to 25, means This is the concrete value, means grade of concrete. This is the graph here we made, and we have to find the target mean strength, and target mean strength formula is Fm is equal to FCK plus 1.65 sigma. Here sigma is the surface tension, and this value is given in our code IS 456 2000. So from that you have to take sigma value. Here if we put 25, so 25 plus 1.65 multiply by sigma, you get the target mean strength for that part. After that, here we introduce loads. This is, you see, the worst conditions. Here we applied the imposed load, dead load, snow load, wind load, all loads here we applied. Now we discuss some difference between all loads, that is the dead load, imposed load, live loads and environmental loads. So dead load contains the loads of constant magnitude and that remain in one position. Means if we cast a beam, the weight of beam is the dead load. So it's remain in one position and that load is constant. Include the weight of the structure as well as other parts that are permanently attached to structures. So beam, column, wall, slab, stairways, these all are the dead loads. Now live loads. Loads that can change in magnitude and position. For example, our furniture, our almirah, all things we have to move from one side to other side. So these are all the imposed loads. We human beings are also the imposed loads or live loads. So these are the example: loads of people, furniture, loads of traffic on bridge, impact load due to vibration of moving load, soil pressure on wall. These all loads are caused by the gravity. And last one is the environment loads. So load caused by the environment in which structure is located. All environment loads are not caused by gravity. So these are the environment loads: snow, ice, rain, wind and seismic loads. So we construct our structure, and when we construct our structure we have to take these loads, dead load, live loads and environment loads. Without these loads we are unable to construct our structure. So these are the loads we consider. So these are the basics, fundamentals of RCC. What do you mean by characteristic strength, characteristic loads? These all things we discuss here. After that, first we have to discuss the design philosophies, in which we have to study about different methods, and after that video we have done singly reinforced beam by WSU. So today's lecture is over. We meet in our next lecture. Thank you.